Naming coordination compounds of transition elements. A complex is a substance in which a metal atom or ion is associated with a group of neutral molecules or anions called ligands. Coordination compounds are neutral substances, uncharged, in which at least one ion is present as a complex. The coordination compounds are named in the following way. To name a coordination compound, no matter whether the complex ion is the cation or the anion, always name the cation before the anion. This is just like naming an ionic compound. In naming the complex ion, name the ligands first, in alphabetical order, then the metal atom or ion. Note, the metal atom or ion is written before the ligands in the chemical formula. The names of some common ligands are listed in the table below. Anionic ligands. Names. Neutral ligands. Names. Br. Bromo. NH3. Amine. F. Fluoro. H2O. Aqua. O2. Oxo. NO. Nitrosyl. O. Hydroxo. CO. Carbonyl. CN. Cyano. O2. Dioxygen. C2042. Oxalato. N2. Dinitrogen. CO32. Carbonato. C5H5N. Pyridine. CH3Cu. Acetato. H2NCH2CH2NH2. Ethylenidyamine. Note: for anionic ligands N and O, for anions that end in ide, e.g. chloride, ate, example, sulfate, nitrate, and ite, e.g. nitrite, change the endings as follows. Ide change to O. Chloride to chloro. Ate change to auto. Sulfate to sulfato. Ite change to eto. Nitrite to nitrito. For neutral ligands, the common name of the molecule is used. Example, H2NCH2CH2NH2, ethylenidyamine. Important exceptions: water is called aqua, ammonia is called amine, carbon monoxide is called carbonyl, and the N2 and O2 are called dinitrogen and dioxygen. Greek prefixes are used to designate the number of each type of ligand in the complex ion, e.g. D-, tri and tetra-. If the ligand already contains a Greek prefix, e.g. ethylenidyamine, or if it is polydentate ligands, it means, can attach at more than one binding site, the prefixes bis, tris, tetrakis, pentakis, are used instead. The numerical prefixes are listed in the following table. Number. Prefix. 1. Mono. D or bis. 3. Tri or tris. 4. Tetra or tetrakis. 5. Penta or pentakis. 6. Hexa or hexakis. 7. Hepta. 8. Octa. 9. Nona or enia. 10. Deca. 11. Undeca. 12. Dodeca. After naming the ligands, name the central metal. If the complex ion is a cation, the metal is named same as the element. For example, Co in a complex cation is called cobalt and point is called platinum. If the complex ion is an anion, the name of the metal ends with the suffix ate. For example, Co is called cobaltate and point is called platinate. For some metals, the Latin names are used in the complex anions. Example, iron is called ferrate, not ironate. The table below shows the names of metals in anionic complexes. Name of metal. Name in an anionic complex. Iron, ferrate, copper, cuprate, lead, plumate, silver, argentate, gold, orate, tin, stannate. Following the name of the metal, the oxidation state of the metal in the complex is given as a Roman numeral in parentheses. To name a neutral complex molecule, follow the rules of naming a complex cation. Remember, name the possibly complex cation before the possibly complex anion. For historical reasons, some coordination compounds are called by their common names. For example, Fe-Cian 6,3 and Fe-Cian 6,4 are named ferrocyanide and ferrocyanide respectively, and Fe-CO5 is called iron carbonyl. Examples: give the systematic names for the following coordination compounds. Cr, NH3, 3, H2O, 3, Cl3. Answer: triaminitria-quachromium, 3, chloride. Solution: the complex ion is inside the parentheses, which is a cation. The amine ligands are named before the aqua ligands according to alphabetical order. Since there are 3 chlorides binding with the complex ion, the charge on the complex ion must be +3, since the compound is electrically neutral. From the charge on the complex ion and the charge on the ligands, we can calculate the oxidation number of the metal. In this example, all the ligands are neutral molecules. Thus, the oxidation number of chromium must be same as the charge of the complex ion, +3. Point, NH3, 5Cl, Br3. Answer: pentamine chloroplatinum, 4, bromide. Solution: the complex ion is a cation, the counteranion is the 3 bromides. The charge of the complex ion must be +3 since it bonds with 3 bromides. The NH3 are neutral molecules while the chloride carries 1 charge. Therefore, the oxidation number of platinum must be +4. Point, H2NCH2CH2NH2, 2Cl2, Cl2 name is dichlorobisophyllenediaminoplatinum, 4, chloride. Co, H2NCH2CH2NH2, 3, 2, so 4, 3 name is triethyllenediaminocobalt, 3, sulfate. K4, Fe-Cn 6. Answer: potassium hexacyanophorate, 2. Solution: potassium is the cation, and the complex ion is the anion. Since there are 4 K+ bindings with a complex ion, the charge on the complex ion must be 4. Since each ligand carries -1 charge, the oxidation number of Fe must be +2. The common name of this compound is potassium ferrocyanide. Na2, NaCl4, answer: sodium tetrachloronickelate, 2. Point, NH3, 2Cl4. Answer: diamond tetrachloroplatinum, 4. Solution: this is a neutral molecule because the charge on point +4 equals the negative charges on the 4 chloroligands. If the compound is point, NH3, 2Cl2, Cl2, even though the number of ions and atoms in the molecule are identical to the example, it should be named diaminodichloroplatinum, 2, chloride, a big difference. Fe, CO, 5. Answer, pentacarbonyluron, 0. Solution, since it is a neutral complex, it is named in the same way as a complex cation. The common name of this compound, iron carbonyl, is used more often. NH4, 2, Na, C2O4, 2, H2O, 2. Answer, ammonium diaquoibisoxyletanoicholate, 2. Ag, NH3, 2, Ag, Cn, 2. Answer, diamine silver, I, dicyanoargentate, I. You can have a compound where both the cation and the anion are complex ions. Notice how the name of the metal differs even though they are the same metal ions. Thank you for watching this video. Don't forget to subscribe and hit notification button, share, like and leave a comment in comment section.